Unit 7, the coordinate plane, Lesson 2, polygons in the coordinate plane. We have 5 vocabulary words for this unit. And the first one is a horizontal line is a straight line that extends left and right. And this is the y coordinates of every point on a horizontal line are the same. So the horizontal line in the coordinate planes all go left and right, and all your y coordinates are going to be on there. And a vertical line, which is straight that extends up and down, those are the x coordinates on this point of the vertical line are all going to be the same. The distance is between 2 points. It is the length of the line segment that connects them. So here you would consider counting all your points between these two, all your units between those 2 points in order to find the distance. And then we have a reflection, which is a flip, and it is a transformation that flips a figure over a line. So if we were to draw a figure on one side of this line here, we're just using the one for distance since it already had a line drawn, and we drew a figure here and we were to reflect it over this, then that would be a reflection, or we would flip it over. We could do it over the x-axis, so we can also do it over the y-axis, or any of the horizontal lines or any of the vertical lines. We also have then the line of reflection, and this is the line in which the figure is reflected. So here's somewhere it actually shows the line of reflection and the figure is being flipped or transformed over that line. You may use your smart device to scan the QR code to watch the Virtual Nerd video on help on how to graph a rectangle in the coordinate plane. We're going to start out with finding distance. Here in this lesson, it's just very simple. We're going to count from one point to the other. Doesn't matter if it's going to be in, quadrant 1, quadrant 3, if it's going to be to the right of the y-axis, left, top of the x, bottom of the x. They will always be a positive value because we're simply just counting from one to the other, and we're going to label it as units. So here in this example, in this coordinate plane, they asked us to find the distance between E and F. So down here is point E, and up here is point F, and you're simply just going to count 1, 2, 3, 4, 5. So the distance between points E and F is a total of 5, and what I would put here at the end is units. Okay? They like to just count it from your x coordinates. So here they're saying that if we take from points E and F, from F is 3 to the x-axis, so that's where they get the 3 here, and E is 2 from the x-axis, and then they add those up. We can just simply just count them. We don't have to actually put a mathematical equation there to find that. So let's practice. Here we have to plot the points. Just going to remind you again, quadrant 1's positive, positive. Quadrant 2, because it goes counterclockwise, is negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. We always start at the origin. So here I have 2 positives, and here I have 2 positives. So that's going to tell me both those points should be here in quadrant 1. So I'm going to go plot my first point. So I'm going to go over 1, 2, 3, and up 4. 1, 2, 3, 4. There's my first point. Again, back at the origin, I'm going to go over 7. 1, 2, 3, 4, 5, 6, 7, and up 4. 1, 2, 3, 4. Now I have my 2 points, and from here I can simply just count the units, how far apart they are. So I'm going to count 1, 2, 3, 4. So these points here have a distance of 4 units. If I look here at number 2, I'm not going to rewrite what my quadrants coordinates are here, but we can use the ones from number 1. I have a negative and positive, which means this should be somewhere here in quadrant 2. It says to go over negative 10, so starting at the origin, and go to the left 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right here. And down 5. 1, 2, 3, 4, 5. So this is really where my point would be. Just mark that so I knew to go down that line, that axis. And then here we have both negatives. Oops, I just noticed that was a positive 5, so I should have gone up 5. Sorry about that. So I went over -10, I go up 5. 1, 2, 3, 4, 5. And I just realized that again because this was a negative or positive, and it should have been in quadrant 3. When I was looking here at the next points, they're both negatives, and they should have been in quadrant 4. So I shouldn't have had that other point there. I'm going to go over a -10 and down -2. 1, 2. Now I'm going to count the distance, which is the number of units. 1, 2, 3, 4, 5, 6, 7. So they have a difference of 7 units. We have 2 more examples down here. I'd like you guys to pause the video, take a couple of minutes, and plot these points. I don't want you to be too worried about these having decimals. Just remember this is like 2.5, so that's going to be somewhere in between. This is a 3.4, 3 4/10, which is close to 3.5. Just do a guesstimate about where those are going to be. And then here, this one should be pretty easy too. So if you pause the video, take a couple of minutes and graph those points and find the distance for number 3 and 4. Now we're going to talk about drawing polygons on the coordinate plane, because that is what this lesson is entitled. Here they give us a scenario. Just say a landscaper or a landscape designer, uses a rectangle that has coordinates -3, 4, 2, 4, 2, 1, and -3, 1 to represent a shed in a yard. What is the perimeter of the shed? And each unit of length represents 1 meter. So what we need to do is first graph these 4 points. So that's what they did here, is they graphed the 4 points. Then they connected the points to make a rectangle. And then when we find perimeter, remember perimeter, or the distance around, is just simply adding the sides. So they're going to find the lengths of those sides and add them. What I like to do is just count the units all the way around. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 units distance between all those points. And remember, they said each one of those represented 1 meter. So we have a perimeter of 16 meters. So we're going to practice that here. We're actually going to have to graph our points on the coordinate plane and then find the perimeter of that rectangle that we draw. So here on number 5, I have 3, -1. So 3, -1 is going to go over right 3, 1, 2, 3, and down 1. Then I have 7, -1. So 1, 2, 3, 4, 5, 6, 7, and then down -1. 3, 8. So here's 3, but this one's a positive, so I'm going to go up. 1, 2, 3, 4, 5, 6, 7, 8. And then we have 7, +8. And then you connect your dots. And I'm not going to do that with this pen because I know it won't connect very well. I won't draw those straight lines. But if you have your pencils, you have a little bit more control of that. But I can still count the distance all around these points. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So I count 26 units for our perimeter. Oh, my pen's not writing. If you don't want to make your little hash marks, when you have those there, you could just simply do our little loops like we did earlier when we were counting distance. So I went over 3, down -1, 7, -1, and 3, 1, 2, 3, 4, 5, 6, 7, 8, and over 7, 8. We could count loops 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. And you still get 26 units. I want you to pause the video, take a couple minutes, graph these coordinates here on number 6. You, again, can connect all the dots with your pencil and count each unit around to find the perimeter. When you are done, then we will move on to the last bit of polygons on the coordinate plane. Now we're going to talk about reflecting points. When you use the x or y axis as the line of reflection, there's a relationship between the coordinates of the reflected points. You're going to plot the points, and then you're going to determine which axis they are reflected, which means flipped, over. So for example here, how is the point 3, 2 related to negative 3, 2? Well, the y-coordinate for each point is the same. If you notice, each of these are the same. They're both positive 2's. And the y-coordinates are opposites. So if you hear 3, and then we have a negative 3. So therefore, the point is reflected over the y-axis because those were the points that were the same. But you can go ahead and plot those points on the coordinate plane. Here's your negative 3, 2, and here's your positive 3, 2. Well, they're opposites, and what is that line that's between them? It is the y-axis. So we're going to do that with the points down below here. On number 7, I'm going to plot 10, 12. 10, 12 is a positive, sorry, so I should be going to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to go up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they don't have 12, so I'm going to make 11 and 12. And there would be my point. And then if I go negative 10, 12, negative 10, and I know that goes up a couple, make my point here, extend my y-axis. Again, notice my x's are opposite and my y-coordinates are the same. So therefore, this is reflected, the line of reflection is the y-axis. I want you to pause the video, take a minute, graph the coordinates here on A, and determine which line that they are reflected over. Is it the x-axis or the y-axis? And when you are done, this is the lesson for polygons in the coordinate plane.